Chapter 8, Section 3, Solving Right Triangles. Your objective is to use trigonometric ratios to find angle measures in right triangles and to solve real-world problems. Don't forget to write your essential question and use your DOK chart. So this is our first example. We need to use trigonometric ratios. So we have cosine of A is 24/25, but we don't know which angle A is, so we need to figure out if it's angle 1 or angle 2. First of all, I'm going to figure out what 24 divided by 25 is. So 24, and I'm using my calculator. I have 24 divided by 25 is going to give, whoops. Where's my delete button? Clear. Oh, that's still 24 divided by 25.96. Alright, so now I need to do the same thing for both of these angles, and I'm talking about cosine. So the cosine of angle 1 is going to be 1.4 over 5, because cosine is adjacent over hypotenuse. So angle 1, the adjacent is 1.4 and the hypotenuse is 5. The cosine of angle 2 would be 4.8 over 5, again because the adjacent for angle 2 is 4.8 and the hypotenuse is 5. So I figure out what both of those are. 1.4 divided by 5 is 0.28, and 4.8 divided by 5 is 0.96. So that means these two match. That means angle 2 is what A is equal to. So angle 2 is angle A, because both of those were equal to 0.96. Again, extra practice problems, page 537, problems numbers 1, 3, and 5. So today in class we talked about sine, cosine, and tangent. Tonight you're going to be working on the inverse of sine, cosine, and tangent, and that's what the negative one means. The inverse of. So we're working backwards. So you're going to take your calculator that you guys picked up today after school, or if you have your own, and you're going to put cosine inverse of 87/100ths. And on mine, my cosine, I don't know if you guys can see that. Let me zoom in real quick. My cosine is here in orange, and then my inverse cosine is there in blue, so I'm going to hit that key, and then it's going to use the inverse cosine. You have to figure out whatever is going to work on your calculator. And if you have a hard time with that, we can talk about it tomorrow. So I'm going to put inverse cosine and then 0.87, and I get approximately 29.5414, and it says that they want you to find the answer to the nearest degree. So we have, our answer is going to be about 30, since that 5 is going to round the 9 up. Next one is inverse sine. So I have inverse, let's clear that, inverse sine, and then you put 0.85. Whoops, it's mad at me because I didn't close the parentheses. And I got 58.2117. Again, it asks you to round to the nearest degree, so this one's going to be 58 degrees. Last one, inverse tangent. Inverse tan, 0.71 or 71/100ths, and I get 35.3748. We're rounding, so my answer is 35 degrees. Page 537, numbers 7, 9, and 11. If you want some extra practice, you can check your answers in the back of the book. Next one, we need to find the unknown measures and round to the nearest hundredth, and the angle measures to the nearest degree. So there's two ways that we can figure this out. The first way is by using the Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared. That means I'm going to have x squared plus 5 squared is equal to 5.7 squared. And then this x is going to end up equaling, if I do the squaring and subtracting, the square root of 7.49. Again, if you put it in your calculator, that is going to end up being 2.74. And what they wanted was measure of angle R. Measure of angle R is going to be, and then we're going backwards because we're using the ratios. So cosine inverse of 5 over 5.7. Again, if you put that in your calculator, put 5 over 5.7 in the parentheses or in the braces so that it does the division first and then it takes the inverse cosine of that number. And you're going to get something that's about 29 degrees. That was measure of angle R, 29. Since these two are going to add up to 90, that's 90, the whole thing is 180, and that means angle T is going to be about 61 degrees. So T is 61, and then R is this 29 degrees. Extra practice, page 537, 13, and 15.
We're paging Damien Pinedo. Damien Pinedo, you need to come to the counseling office immediately. Damien Pinedo.
All right, last one. You have the coordinates, and then there's P, Q, and R, and they're already graphed here. So P is negative 3, 3. That one's P. Q is 2, 3. And then R is negative 3, negative 4. And it's asking you to find the side lengths to the nearest hundredth and the angle measures to the nearest degree. PQ is easiest and PR is easiest because those are vertical and horizontal lines, so you can just count. So that's 1, 2, 3, 4, 5. PQ is 5. 1, 2, 3, 4, 5, 7. Double check it. 3, 6, 7. Good. All right, and then this one. Again, you can use Pythagorean theorem or you can use the distance formula. So we're going to use the distance formula for QR. That's going to be the square root of negative 3 minus 2 squared plus negative 4 minus 3 squared. And that is going to end up giving us about 8.6. All right. And then we also need to find the angle measures. Angle P we know is going to be 90. This we said was 8.6, this distance. And then to find angle Q, we need to find the inverse tangent. We're going backwards. We have the ratio. And then for angle Q, the tangent is going to be 7 over 5. So if I put inverse tangent and then 7 divided by 5 in my calculator, close the parentheses, you're going to get 54 degrees. And then if angle Q is 54, angle P is 90, they're all going to add up to 180. And so 180 minus 90 minus 54 is going to give me the measure of angle R is 36 degrees. If you have any questions, you guys can help each other out or in class tomorrow, or you can post your questions on Edmodo tonight, and I will do my best to get back to you. extra practice, page 537, problems number 17 and 19.